For 6c, we'll do the same thing. We are looking for the limit as h approaches 0 of f of x plus h minus f of x all over h is the definition we're using. So now we're going to plug x plus h into our function. So that will give us 1 over x plus h, and then we'll just take the function, 1 over x all over h. Now what we notice is that we need to get rid of two denominators here. So we need to multiply by a form of 1 that'll cancel out an x, and that'll cancel out an x plus h. So we need to take the product of those. And then when we distribute, what we'll notice is when I multiply this fraction by this term, the x plus h will cancel out, leaving me with just x. When I multiply those two together, what will cancel is the x, leaving me with the quantity x plus h. I'm putting that in parentheses so I don't miss the fact that I'm distributing the negative over both of those. In the denominator, we just have h times x plus h. Now let's finish this up. We're looking for the limit as h approaches 0. And in the numerator, I'll have x minus h. So negative h over h times x plus h. Those h's will cancel out. So really, I'm looking for the limit as h approaches 0 of negative 1 over x times x plus h. And now I know that it's going to be safe to plug in h is equal to 0, so this will just go away. So I'm really left with negative 1 over x times x, which is x squared. This is, again, a little bit interesting because I know that this, which gives the instantaneous rate of change, which gives the slope of the tangent line, this is always negative. No matter what I plug in for x, that's always going to be negative. And if I look at the graph of 1 over x, which is one of these hyperbolas, that makes sense. No matter where I draw a tangent line, it certainly seems as though the tangent line should have negative slope, as suggested by our derivative, in fact. The other thing I know, how I can interpret this, is that if I am traveling from left to right along this function, coming down here, or if I'm on this branch, the function's always decreasing. I'm always going down on the function, sliding down the function.